Hello everyone. In the last section, we have introduced the construction of CNN. In this section, we will talk about convolution layer in CNN. Convolution is the first layer to extract features from an input image. It preserves the relationship between pixels by learning image features using small squares of input data. It is a mathematical operation that takes two inputs, such as image matrix and a filter or kernel. Convolution has the nice property of being translational invariant. Intuitively, this means that each convolution filter represents a feature of interest, such as pixels in letters, and the convolutional neural network algorithm learns which features comprise the resulting reference, such as alphabet. A digital image in a computer is presented by pixels matrix, such as this digital grayscale image. We want to present it in the computer by pixels matrix. Each pixel of such image is presented by one matrix element, an integer. The numeric values in pixel presentation are uniformly changed from 0 black pixels to 255 white pixels. Color image with RGB color model in a computer are presented with 3 grayscale images matrices, one for each red, green, and blue color components. In convolutional neural network, the kernel is a filter that is used to extract the features from the images. The kernel is a matrix that moves over the input data, performs the dot product with the subregion of input data, and gets the output as the matrix of dot products. Kernel moves on the input data by the stride value. If the stride value is 2, then kernel moves by 2 columns of pixels in the input matrix. In short, the kernel is used to extract high-level features like edges from the image. Now let's look at how to calculate the convolution of an image. Consider a 6 by 6 grayscale image and the filter matrix 3 by 3. It is shown here. The value is 0. Then we calculate the second value. It is shown here. The value is 30. We calculate all the numbers one by one. After convolution, a 6 by 6 image is converted to a 4 by 4 image. Convolution of an image with different filters can perform operations such as edge detection, blur, and sharpen by applying filters. Stride is the number of pixels shifts over the input matrix. When the stride is 1, then we move the filters to 1 pixel at a time. When the stride is 2, then we move the filters to 2 pixels at a time, and so on. The below figure shows convolution would work with the stride of 2. Sometimes, filter does not perfectly fit the input image. We can pad the picture with zeros, called zero padding, so that it fits. Otherwise, we must drop the parts of the image where the filter doesn't fit. This is called valid padding, which keeps only valid parts of the image. ReLU stands for rectified linear unit for a nonlinear operation. The output is fx equals max 0x. Why ReLU is important? ReLU's purpose is to introduce nonlinearity in our ConvNet. Since the real-world data would want what our ConvNet to learn would be non-negative linear values. There are other nonlinear functions, such as sigmoid, that can also be used instead of ReLU. Most of the data scientists use ReLU since performance-wise, ReLU is better than the other. This is the end of this section. Thanks for watching and welcome to the next period.